We will talk about hyperbolic and inverse hyperbolic functions. So let's start with defining what we mean by the hyperbolic sine and cosine functions. So, yung definition nito nakabase dun sa natural exponential functions natin, ano? So, yung sinh of x is e to the x minus e to the minus x over 2. Yung cos x natin magiging plus lang yung sine. So let's try to evaluate expressions na nag-involve nitong mga functions na to. So kunwari, sinh of 0. So using the definition, you get e to the 0 minus e to the minus 0 over 2. Tapos alam natin magiging 1 parehas yun. So basically, sinh of 0 is equal to 0. Cos of ln 2. So kapag i-plug in mo yung values, magiging ganito siya. Pero hindi tayo titigil dito. Kailangan natin maalala yung properties ng ln natin. So in particular, yung negative sign, pwede mong iakyat doon. So magiging ln of 1/2 yun. And then gamit ka ng properties ng natural exponential and logarithmic functions to simplify para makuha mo ang sagot na 5 over 4. And then these are the hyperbolic tangent, cotangent, secant, and cosecant functions. Ako mas madali ko maalala to kung naaalala ko yung trigonometric functions natin. No? May hint kung paano mo siya maaalala. Okay, so isa-isayin lang natin yung tanh x natin, e to the x minus e to the minus x over e to the x plus e to the minus x. Yung coach x, kamukha niya si tanh, pero pinagbaliktad lang natin yung numerator at sa denominator. Sech x natin, ito familiar din dapat siya, ano? So 2 over e to the x plus e to the minus x. Ang cosech x ay 2 over e to the x minus e to the minus x. Try natin mag-evaluate na expression sa meron nitong mga to. So tanh 1. So sana pakialala yung ating formula. So pag sinalpak mo at i-simplify, you get e squared minus 1 over e squared plus 1. Coach of ln 3. Mga ilang segundo natin gawin. Ang final answer should be 4 over 5. Sech of ln 2. So actually, kung ginawa natin yung cos ln 2, madali na dapat ito and some theorem. Okay, pero using definition, you get this is also 4 over 5. And lastly, cosech of 1. This is 2e over e squared minus 1. So in case you need to evaluate limits involving hyperbolic functions, maganda na malaman natin yung behavior ng graph natin, ano, para madali nating masagot yung mga yon. So here are the graphs of sinh x and cos x. So some exercises. Let's say you want to evaluate the limit of sinh x as x approaches positive infinity. So looking at the graph, the answer should be equal to positive infinity. So isa pang tanong, what if you want to evaluate the limit of sinh x as x approaches 0 from the left? So looking at the graph, the answer should be equal to 0. And then move on tayo sa cos. So let's say you want to evaluate the limit of cos x as x approaches 0. So yung sagot natin dapat ay equal sa 1. So you look at the y values. Let's say you want to evaluate the limit of cos x as x approaches negative infinity naman. So ang sagot natin ay positive infinity. So let's say we consider yung tanh x natin. So what is the limit of tanh x as x approaches positive infinity? So ang sagot ay positive 1. Limit ng tanh x as x approaches negative infinity should be equal to negative 1 naman. So makikita natin sa graph. So here is the graph of cos x. So ang limit ng cos x as x approaches negative infinity ay negative 1. And yung limit ng cos x as x approaches 0 from the right ay positive infinity. So here's the graph of sech x. Ano kaya ang limit ng sech x as x approaches positive and negative infinity? So medyo pares kasi nangyari sa kaliwa at kanan, ano? So ang sagot dito ay equal to 0. And here's the graph of your cosec x. So what is the limit of cosec x as x approaches 0 from the left? So this is negative infinity, seen on the graph. And what is the limit of cosec x as x approaches negative infinity naman? So it should be equal to 0. So if we are to compute expressions involving hyperbolic functions naman, it helps to know yung mga identities relating them. So hindi lang sila sa notation nagkakaparehas, ano, pati yung mga identities na nag-i-involve sa kanila ay halos magkakamukha din. So let's say you have your reciprocal at saka quotient identities for trig functions, kaparehas sila ng hyperbolic. So konting ano lang, sech x is just the reciprocal of cosh x, cosec x ay 1 over sinh x, at ang coch x ay 1 over tanh x. So for the quotient identities, parang ang tangent x mo ay sin x over cosine x, ganun din for hyperbolic functions. So tanh x ay sinh over cosh, tapos yung coch naman ay cosh over sinh. Tapos since from the definition, medyo simple yung itsura ng hyperbolic sine at sa cosine natin, may extra identity tayo dito. So cosh x plus sinh x equal yan kay e to the x, at ang difference naman ay e to the minus x. And then meron tayong cosine squared x plus sine squared x equal to 1. May counterpart yun for hyperbolic pero medyo mag-iiba yung sign. So ang cosh squared x minus sinh squared x ay equal to 1. And since nagbago yung sign nito, mag-iiba din yung iba nating Pythagorean identities relating tanh and sech, coch and cosec. So take note lang yung difference ito from the usual Pythagorean identities involving trigonometric functions. Meron din tayong double measure or double angle identities. Yun yung tawag natin minsan sa trigonometric identities. So, yung sin 2x natin, it is equal to 2 sin x cosine x. For hyperbolic functions, medyo ganun din. Sinh 2x is just 2 sinh x cos x. Again, yung usual na pagkakamali, kapag gusto mong kunin yung sinh 2x, hindi lang ilalabas yung 2 doon. And for cos 2x, so nakalagay in red yung cosine 2x equal to cosine squared x minus sine squared x, hindi lang nilabas yung 2. So for cos, ganun din, mag-iiba lang yung sine. And then yung dalawa pang equality, pwede rin silang in place of cos squared x plus sin squared x. Kahit ano sa mga yan, pwede nyong gamitin. And then we also have yung sum and difference identities, si cos cosine sin at saka sin cos cosine. Okay, so kunwari cos x plus or minus y, cos plus or minus sinh. And for sinh x plus or minus y, you have sinh cos plus or minus cos sinh. So let's try to prove some of the identities, in particular yung 3 and 5. So cos x plus sinh x. So sabi ko nga nako-follow lang to immediately from the definition. So recall, pag may time. Simplifying terms, you get this, which is equal to e to the x. And let's say you consider cos squared x minus sin squared x. I hope na recognize natin that this is a difference of two squares. So factoring it out, we get this. And assuming na prove na natin yung isa pang identity na ang cos minus sin ay e to the minus x, pwede na natin gamitin yon. So this is equal to 1. Isa pa to na usual na problem sa trigonometric. You have your trig function, one trig function you are to compute for the other trig functions. Pwede rin natin gawin yun for hyperbolic functions. So dito given si tanh, how do you get the other hyperbolic functions? So, yung pinakauna na kukuha talaga ay using your reciprocal identities. So, since si tanh x ay 12/13, so ang coach natin ay 1 over yon, which is 13 over 12. How about sech x? So, dito papasok ko yung tinatawag natin Pythagorean identity. So, naka-red siya. Bakit? So, square root ng 1 minus tan squared x. Kasi dun sa Pythagorean identity, naka-square din si sech. So, dito we get the square root. And if we get the square root, usually we use plus or minus. Pero dito, plus lang yung kinuha natin. Bakit kaya? So, malalaman ang sagot from the graph of sech x. Ay, tignan nyo na lang. So, plugging in the value of tan x and simplifying, we get 5/13. So, madali mo makuha yung cos x, reciprocal identity ulit. And then si sinh x, paano naman to? Paano kaya? Gamitin mo naman si quotient identity. May cross multiply ka lang doon. And then plugging in the values and simplifying, you get this. And yung last natin ay cosech, nagagamit ka lang ng reciprocal identity. Let's look into the inverse hyperbolic functions. So recall that to be able to define the inverse of a function, the function should be a one-to-one function. Pero going back to our graphs, we see that yung cosh and sech natin are not one-to-one. So what we do is we restrict the domain of these functions to 0 to positive infinity para maging one-to-one na sila. So here we try to express the inverse hyperbolic functions in terms of your natural logarithm. So pakikabisado na lang sila. We show the proof of the first statement. So let's say let y be equal to sinh inverse x. So that means x is equal to sinh of y. And kailangan natin maalala yung definition ng sinh natin. So e to the y minus e to the negative y over 2. And then cross multiply 2, we get this equation. And then cross multiply ulit si e to the y. And then dito, we need to rearrange terms para lang ma-recognize that this is actually of quadratic form. So we make use of our quadratic formula. So parang tinitreat mo dito 2x is a constant, no? So we just simplified yung terms na nasa loob ng square root. So recognize na may 4 parehas, so you can factor it out. And then kapag nilabas mo siya sa square root, it becomes 2. And then canceling out terms, you get this expression. Tapos ano kaya mapapansin natin? X plus square root of x squared plus 1 is definitely non-negative. Actually positive siya. Pero kapag kinuha mo yung minus, it becomes negative. So dito, we get na yung e to the y is just equal to x plus square root of x squared plus 1. Hindi pwede yung minus. So recall nyo lang yung definition ng exponential at saka logarithm to get this expression. So let's try to evaluate using yung inverse hyperbolic functions using yung kanina nating theorem. So kunwari yung sech inverse of 1. So nasaan yun? So number 5. So equal to ln of this expression. Salpak-salpak lang. So simplify, that is equal to 0. So coach inverse of 5/4, we are looking at number 4 sa theorem. So 1/2 ln itong bagay na to. And then simplifying, you get 1/2 ln 9/4 over 1/4. So that is 1/2 ln 9. So simplify lang natin, that is equal to ln 3. So we may also need to evaluate limits involving inverse hyperbolic functions. So para masagutan yung mga yon, we need to know the graphs of these functions. So ito yung kay sinh inverse at saka kay cosh inverse x. So let's say, for example, you want to evaluate the limit of sinh inverse x as x approaches positive infinity. So looking at the graph, the answer should be equal to positive infinity. What if you evaluate the limit of sinh inverse x as x approaches negative infinity naman? So ang sagot should be equal to negative infinity. And then to the right, you have the graph of cos inverse x. So what if we are to evaluate yung limit ng cos inverse x as x approaches 1 from the right? So ang sagot ay equal to 0. So what if naman ang gusto mong evaluate ay limit ng cos inverse x as x approaches positive infinity? So again, from the graph, yung answer natin doon ay positive infinity. So here's the graph of tan inverse x. So the limit of tan inverse x as x approaches 1 from the left ay equal sa positive infinity. So what if you are to evaluate yung limit ng tan inverse x as x approaches 0 from the right? So ang sagot ay 0. Here is the graph of cos inverse x. So what if you want to evaluate the limit of cos inverse x as x approaches negative 1 from the left? So nakatingin tayo doon sa kaliwa. So habang pumupunta ka kay negative 1, the y values approaches negative infinity. So what if naman limit of cos inverse x as x approaches positive infinity? Y values approach 0. So dito tayo kay sech inverse x at saka cosec inverse x. So the limit of sech inverse x as x approaches 1 from the left at ang limit ng cosec inverse x as x approaches negative infinity, meron kaya silang pagkakaparehas. So kay sech inverse, punta ka kay 1 from the left. Kay cosec inverse, punta ka kay negative infinity. So ang sagot kasi parehas equal to 0. What if evaluate the limit of sech inverse x as x approaches 0 from the right? So looking at the graph, diba yung y values natin nag-approach sa positive infinity. So again, the limit of sech inverse x as x approaches 0 from the right is positive infinity. So let's look at yung cosec inverse naman. What if we are to evaluate the limit of cosec inverse x as x approaches 0 from the left? So habang pumunta ka kay 0 from the left, the y values go to negative infinity. So yung sagot ulit natin, yung limit of cosec inverse x as x approaches 0 from the left is negative infinity. Kunwari lang, no, nag-wonder tayo, bakit kaya hyperbolic functions ang tawag sa hyperbolic functions? Balikan lang muna natin yung trigonometric functions, ang tawag din sa kanila ay circular function. So bakit? Kasi para makompute sila, you look at the unit circle, and then kunwari si t ay positive, so para makompute yung cosine t, sine t, you measure from the point 1, 0, t units along the unit circle counterclockwise. So, kung saan ka titigil, so yung dot na yan, yun yung cosine t, sine t natin. Now, for the hyperbolic functions, binabase natin yung pag-evaluate doon sa unit hyperbola na ang formula or ang equation ay x squared minus y squared equal to 1. So, kunwari si t ay positive, how do you compute for cos t at saka sin t? So, again, from the point 1, 0, so sa kanan tayo nakatingin, we measure t units along the unit hyperbola. So, if t is positive, so pataas. So, kung saan titigil yung dot mo, so kunwari dito, yan yung lalabas na cos t at saka sin t natin.
Hello, this is Sir Prince and ngayon, natapos na ninyong panoorin yung mga lecture on different classes of functions. Nung nakaraang dalawang topic, na-tackle yung trigonometric, logarithmic, exponential, and inverse circular function. Pinanood niyo yung lecture ni Dr. Damasco, tapos naglagay din ako ng ilang mga clips. Then, kani-kanina lang, ang inyo namang nakita ay ang mga hyperbolic and inverse hyperbolic functions na siyang didiscuss ni Dr. De La Cruz. Ngayon, pagsama-samahin natin yung mga functions na ito sa isang limit problem. Halimbawa, ang goal natin for this part is to answer the following exercises. Okay? So, dito, syempre, may mga mahalagang impormasyon na kailangan alam natin about the functions involved. Una, we need to know the domain of the functions. Kasi, di ba, ang ilan sa kanila, kapag naman part na ng domain yung ina-approach ni X, you can simply evaluate. So, kung alam natin yung domain, maybe we can lessen the number of things that we have to think about sa ating problem. Kasi baka naman pwedeng mag-evaluate na lang. Next, ano pa bang makakatulong sa atin? Dito nakikita natin yung ln function, logarithmic yan. Logarithmic din. Tapos meron tayong exponential, let's say 4 to the x, 1/2 to the x. Diba? So maganda, kapag logarithmic and exponential functions pinag-uusapan, malaman natin kung ano ba yung nangyayari sa base. I-compare natin siya sa 1 to be specific. Siya ba ay less than 1 but greater than 0 o greater than 1? So base of the exponential or the logarithmic function. Nakikita din natin sa problem yung existence ng sinh function, hyperbolic sign, at yung cos. Ito, meron dito. So, alalahanin natin, ano ba yung sabi kanina sa lecture part? Ang sinh or hyperbolic sign of x is equal to half the difference of e to the x and e to the negative x. On the other hand, the hyperbolic cosine, cos x, is equal to the half of the sum of e to the x and e to the negative x. And lastly, isa pang mahalaga, kapag hindi pwede mag-evaluate lang basta-basta, tumitingin din tayo sa mga graph ng mga functions. Okay? Sige, let us start. For the first one, x squared minus ln x as x approaches 1. Again, the very first step that you have to do is to check if the value that x approaches to is part of the domain. So, x squared is a polynomial. Hence, 1 is in the domain of x squared. Kaya pwede tayo mag-evaluate lang for the limit of the first term. Now, for the second term, ln x, ano nga ba ang domain ng mga logarithmic functions? Zero to infinity, di ba? So si 1, pasok naman dun sa domain ni ln x. So this one can be evaluated, and hence, this is simply equal to 1 squared minus ln 1. Okay, I'll give you a few seconds to think about ano po ang value niyang 1 squared minus ln 1. I'll give you 5 seconds, ha? Okay, so 1 squared, madali lang yan. It is equal to 1. And ang ln 1 ay saan equal? Sa 0, di ba? So this is equal to 1. Let us proceed to the next example or the next exercise. Ito ay maraming involved na function. Nakikita natin ang hyperbolic sign, ang exponential function with base 4, at ang inverse sine function. Pero ang kagandahan dito, ina-add lang naman natin sila. So we can check the limit per term. So the question, again, is 0 in the domain of each of the terms? Ano ang domain ng sinh function? Ano ang domain ng 4 to the x? Ano ang domain ng sine inverse function? Sige nga po, pakipag-isipan yon. Domain. Ayan. So ano po ang mga domain niyang functions na yan? Si sinh, ang domain niya ay r. So, negative infinity to infinity. Ganon din naman ang exponential functions, negative infinity to infinity din. At ang sine inverse naman ay mula negative 1 to 1. Okay? Yan yung domain nila. So, si 0, pasok naman sa lahat ng yan at hindi endpoint. So, here, we can simply evaluate. So, we get sinh of 0 plus 4 to the 0 plus sine inverse of 0. Etong sinh 0, kung hindi nyo pa naaalala agad kung ano yung value agad-agad yan, we can recall that the sinh, the hyperbolic sine function is equal to e to the x, so e to the 0, minus e to the negative x, so e to the negative 0, divided by 2. Okay po? Then plus 4 to the 0, then plus sine inverse of 0. So parang dito, ano yung nagbibigay ng sine na equal sa 0? Sige, I'll give you 15 seconds. Please compute the value of this one. Okay, so let's see. Ang non-zero raised to 0, it is equal to 1. Property yun ng exponential function, di ba? So here we get 1 minus e to the negative 0. That's the same as e to the 0. So we get 1 still. Ito, we are raising again a non-zero number to the 0. So we get 1 pa rin. And anong sine inverse 0? Anong angle ang nagbibigay ng sine equal to 0? Diba 0 radians? So we get here 0. So simplifying, we get 0 plus 1 plus 0. So we get 1. So take note na special value ang hyperbolic sign when we have x equals 0 kasi ang hyperbolic sign of 0 ay equal lang sa 0. And kung gusto niyo yung hyperbolic cosine naman, ang hyperbolic cosine of 0 ay equal sa 1. But if you are not, but if you do not remember that, again, you can express the hyperbolic sine function as e to the x minus e to the negative x all over 2. Katulad ng ginawa natin dito. Okay po? Sige. Let us proceed to the next one. Dito, involved ang logarithmic function at exponential function. Tignan natin kung nasa domain ba yung ina-approach ni x. Dito, wala. Kasi sabi ko kanina, ang logarithmic function ay may domain na 0 to plus infinity, pero si 0 hindi included. So dito, si 0 ay hindi parte ng domain ng logarithmic function. Sa pangalawa, parte siya. So we can evaluate in the second one. So sige nga po, ano po ang sagot natin dito? Bigay ko na rin siguro yung graph. Baka mas familiar kayong interpret ng limit of logarithmic function kapag binigay yung graph. So ito yung graph ng logarithmic functions and exponential functions. Kayo na mag-analyze kung alin dito sa dalawa yung kailangan nyo talaga, ha? Okay, so please solve this limit problem in kayang 30 seconds. Kaya, no? Okay naman, 30 seconds. Again, you just look at the graph para sa logarithmic. Tapos para sa exponential, you can just evaluate. So sige, I'll give you 30 seconds. Okay, let's do this. So ano yung madaling part again dun sa exponential kasi 0 is in the domain of the exponential function. Kasi again, exponential functions have domain equal to the set of all real numbers. So yung pangalawa, it is easy. We just get the limit as x approaches 0 from the right of log of x to the base 1 over 5. And then ito nga, we can just evaluate at 0. So we get 1 over 3 raised to 0. Simplify ko muna ito ha. So this is equal to 1 kasi non-zero, raised to 0 na naman tayo dito. So we get a limit as x approaches 0 from the right of logarithm of x to the base 1 over 5 plus 1. Okay, so let us observe the graph of the logarithmic function. 1 over 5, again, if you have a logarithmic and exponential function, na nangyayari, compare the base kay 1. It is between 0 and 1 o mas malaki sa 1. 1 over 5 is smaller than 1, but it is bigger than 0. So, saan pasok yan? Dito sa ikalawa. Tama ba? So, if we have x approaching 0 from the right, so we have here x equals 0. Gusto natin from the right. So, from the right going to 0. Ang graph natin, pataas lang ng pataas yung kanyang function value. So, dyan, we get plus infinity. Okay? So, this is equal to plus infinity plus 1 using the graph. Pero paano if we don't have the graph? Wari, wala yan. Then again, ang nangyayari kasi dito, parang ang tanong natin sa sarili natin, ano yung dapat exponent ni 1 over 5 such that ang value ng 1 over 5 to that exponent will be very, very close to 0. So, meron tayong 1 over 5. We will raise that to some y. Gusto natin mag-approach ng 0 ito. So, paano mo ba papalitin ng papalitin lalo yung value ng 1 over 5? Di ba pwede mo siyang i-multiply sa sarili niya ng sobrang daming beses? Kasi kapag multiply mo siya sa sarili niya, ang nangyayari lang ay, ang lumalaki lang talaga ay yung denominator kasi ang numerator ay fixed na equal to 1. So, if we have 1 divided by a very large positive number, we will simply get 0. Okay? So that's another way to see why the value of the limit or why the limit of this logarithmic function with base 1 over 5 as x approaches 0 from the right is plus infinity. But if you have the graph familiarized, then this is okay. And it is easy to just look at the graph. Sige, let us proceed to the next one. Okay. So kanina, sa previous 3 examples, what we do is to consider 3 sums lamang or difference. So mga sum lamang at mga difference ng different classes of function. Pero dito, we are now composing 2 functions with each other. Kapag ganyan na may composition, ganito lang lagi yung kailangan yung isa-isip, okay? Start with the innermost function. Then papalabas. Again, start with the innermost function. Do not forget that, Start with the innermost function and kahit pa gaano karami yung kinocompose, huwag kayong magpapanik masyado. Kakalma lang kayo. Tapos, kailangan nyo lang ma-realize na kapag may composition of functions ka, you start with the one that is the innermost function. So, dito we are talking about the function e to the tangent x. So yan ay e to the x, but instead of x, you replace that by tangent x. So dito ang innermost function ay tangent x. So we start with tangent x. So as x approaches 0, tangent x approaches 0 is in the domain of the tangent function. Kasi ang domain ng tangent function ay, anong domain yan? Lahat ng values of x such that the cosine function is not 0. Kasi di ba ang tangent ay sine over cosine. But when x is 0, ang cosine natin ay cosine of 0. That is equal to 1. Hindi naman 0 yon. So this will approach the function value lamang. So we have tangent of 0. So what is tangent of 0? Kung hindi nyo naaalala yung mga special values, you can express this in terms of sine and cosine. So we have sine of 0 divided by cosine of 0. but sine of 0 is 0, and cosine of 0 is equal to 1. So we have 0. Okay? So solve na tayo dun sa part ng tangent x. Tapos papalabas lang tayo. Okay na sa tangent x, ang next na ay yung exponential with base e. At yung natural exponential functions. So here, as x approaches 0, e to the tangent x will approach e to the, ano yung ina-approach ng tangent x? 0, di ba? Okay? But ano nga po ulit ang e to the 0? What is the value of e to the 0, class? Ang value ng e to the 0 ay yung pinakamataas na possible grade sa UP. So it is equal to 1. So this is equal to 1. And ayan na. Natapos na natin mula sa pinaka-inner na function papalabas. Nakuha natin na ang final answer ay equal to 1. Okay. Next. E to the tangent x as x approaches pi over 2. So katulad nung kanina, ganun pa rin. We are composing e and tangent x. And ang mas nasa loob ay si tangent x. So as x approaches pi over 2 from the right. Okay class, my question is, si pi over 2 po ba ay parte ng ating domain for the tangent function? It is part of the domain. Yes or no? Yes ba ang sagot mo? O no? Sa mga nagsabi ng no, sigurado ba kayo? Sa mga nagsabi ng yes? Tama ba na yes? Alalahanin natin ng tangent function ay equal sa sine over cosine. So para nasa domain, kailangan ng cosine ay hindi 0. So question, is cosine pi over 2 equal to 0? Di ba yes? So the answer is pi over 2 is not in the domain of tangent x. So dito hindi tayo pwede basta-bastang mag-evaluate. We have to analyze the problem. Kung alam mo yung graph ng tangent x, you can get the limit. So let's say this one, ito ang graph ng tangent x. Gusto mo ay from the right of pi over 2. So saang part na yun? Oops, sorry. Nasa na tayo? Ito yung pi over 2. Gusto mo from the right, so mula dito sa part na ito. So ito yung portion na yun ng graph. So it approaches negative infinity. So that is using the graph. Now, an alternative way na madali pa rin naman gawin kahit papaano ay, again, ito ay negative infinity na ha, using the graph. So kung familiar na kayo sa graph, okay na yon. But if not, another way to evaluate this is to observe that tangent x is sine x over cosine x. So as x approaches pi over 2 from the right, we get tangent x approaches sine of pi over 2, yun ay 1. Cosine of pi over 2 ay 0, but we have to know if it is from the right or the left. So consider natin yung ating mga angles. Ang pi over 2 regions ay dito sa part na ito, dito. So ang mas malaking angle sa kanya ay kapag nasa quadrant 2 ka na. So dito ano yung cosine? Is it negative or positive? Negative po, di ba? So we have 0 minus. And hence, this is negative infinity. Okay. Alam na natin yung limit nung innermost function. We then proceed to the outer. So we get as x approaches pi over 2 from the right, si e to the tangent x will approach e to the negative infinity. Pero ano ang ina-approach ng e to the negative infinity? Zero. Tama. Pwede mo kasing isipin na this is 1 over e to the plus infinity. So, si e ay greater than 1. So, ang denominator ay palaki lamang ng palaki. So, we have 0. Okay? So, this is our answer. 0. Okay, ito naman. Let's do this. So, dito, marami-raming function ang involved. But again, chill lang tayo, kalma lamang. We just need to start with the innermost function. So, we start with 1 over x, and then with cotangent inverse of 1 over x, and then with 1/3 cotangent inverse of 1 over x, and then finally, cosine ng 1/3 cotangent inverse x. Okay? So, the idea again, kapag may composition kayo nakikita, basta kahit pa ilan yan, start with the innermost function. Okay? So, dito, as x approaches 0 from the left, ano yung innermost ulit? Yung 1 over x muna. So, 1 over x approaches 1 over 0 minus. Ito ay saan pupunta? Anong value yan? Or anong, kung hindi man value, ano yung notation para dito? We are dividing a non-zero by a zero. So, we have an infinity. But we have to know what sign, what infinity. It is negative or positive. So, ang 1 may positive sign yan. Ang 0 minus, we see the minus. So, plus divided by minus, we get negative infinity. Okay? Okay na. Check na itong isa. Tatlo na lang. Cotangent inverse, 1/3 of that, then cosine of that. So, we get, we will obtain next yung as x approaches 0 naman from the left ng cotangent inverse of 1 over x. Okay? So, this will approach the limit of cotangent inverse function as the expression inside it approaches negative infinity. So, lagay ko na lang ito as cotangent inverse of negative infinity, okay? Tingnan natin yung graph ng cotangent inverse. So, ito yun. Cotangent inverse of negative infinity. So, gusto natin papuntahin ang ating input for the cotangent inverse sa negative infinity. So, we have aling part dyan. Pakikuha nga po, ano po ang sagot? Again, what we want is the limit of the cotangent inverse function when the input approaches negative infinity. So, dito lang, di ba, pakaliwa lamang tayo ng pakaliwa kasi nga, gusto natin papuntang negative infinity yung input. Okay? So, kapag pupunta ka sa kaliwa, asymptotic lang yung cotangent inverse sa line na y equals pi. So, we get that this value is equal to pi. So, the limit as the input or the expression inside the cotangent inverse approaches plus infinity ay equal po sa pi. So, okay na tayo dito. Next, yung may 1/3 naman. So, as x approaches 0 from the left, 1/3 cotangent inverse of 1 over x approaches, o ano ina-approach nito? 1/3 is a constant lang ha. So, kung 1/3 ay constant, tas alam mo yung limit ng cotangent inverse of 1 over x, then ano lang po yung limit ng constant multiplied by cotangent inverse of 1 over x? Ano po yung limit? Multiply mo lang sa 1/3, yung nakuha mong limit kanina. So, we get 1/3 times pi. Okay? So, this is pi over 3. And yay! Last one. Cosine na lang. So, as x approaches 0 from the left, the limit of cosine 1/3 cotangent inverse 1 over x, saan equal yan? So, pi over 3 is in the domain of cosine function, kaya you will just evaluate. So, what is the value of cosine of pi over 3 po? This is in radians, ha? In degrees, pi over 3 is equal to 60 degrees. Ano ang value nun? Special angle yan. Ano ang value ng cosine of pi over 3? Alalahanin. Is it 1/2 or square root of 3/2? O may iba ba kayong sagot bukod doon? Ano po ang cosine pi/3? What is cosine 60 degrees? Ang sagot ay 1/2. Ayan. So, okay na. Nagawa natin lahat. So, this is equal to 1/2. And tapos na. Okay na rin tayo dun sa pinaka-nasa labas na function. And hence, we get that this limit is equal to 1/2. Kaya tingnan natin itong final na problem para sa discussion na ito. Una, pansinin natin na itong limit problem na ito ay merong dalawang factors. So we will multiply e to the cos or e to the hyperbolic cosine of square root of ln x. Ito yung unang term. And yung pangalawang term naman ay cosine inverse of 4 to the negative x. So ito, composition ito ng e to the x, hyperbolic cosine, square root function, at ln function. Ito namang pangalawa, ito ay composition of inverse cosine and an exponential function. Okay? Ito pwede mong isipin as 1 divided by 4 to the x lang din naman. Kaya, ang gagawin nyo dyan ay paghiwalayin nyo muna sila. So, get the limit of this, get the limit of this. If hindi naman interminate, then you will just multiply the limits. And again, ang sinasabi ko kanina ng paulit-ulit, you start with the innermost function. So, para sa unang factor, you start with the innermost. So, mula dito, papalabas. And for the second factor, you start with the innermost ulit. So, magkaiwalay sila, ha? Yun yung gawin ninyo. Iwalay yung mula innermost hanggang outermost dito, sa innermost hanggang outermost dito. And ito na rin yung mga graph. Subukan nyo nang kuhanin yung mga limit using the graph. I-familiarize nyo na yung mga sarili ninyo sa mga graph at kung paano ba mag-interpret nga ng limit using the graph. Sige, I will leave you first. Actually, hindi pala ako aalis. Actually, hindi nyo nga ako kasama now kasi nanonood lang kayo. So anyway, ang ibig sabihin ko lang ay ipopause ko muna yung screen na ito. You don't have to pause this. So tatakbo lang yung oras dito na walang nangyayari sa screen ng 6 na minuto. Okay? So bigyan ko kayo ng 6 na minuto para isolve ito. 6 na minuto lang kasi, again, titingin lang kayo sa graph. So wag niyo masyadong i-overthink. You will just look at the graph and interpret the limit using the graph. Dahan-dahan lamang. Okay? So dito, ang innermost ay si ln x. Ang ln x as x approaches plus infinity, saan ang punta niya? Ang ln x ay may base na e, which is bigger than 1. So, ito yon. So, as x approaches plus infinity, pupunta rin ng plus infinity yung ln x. So, itong part na ito ay pupuntang plus infinity. Next, square root of plus infinity. Saan pupunta? Okay na ako sa ln, ha? Next na tayo, dun na tayo sa square root function. Kapag meron kang very, very, very big positive number, ano ba ang square root niya? Di ba positive din naman na very, very big? So we get here, approaches plus infinity. Okay na sa square root. Next, hyperbolic cosine. Para sa hyperbolic cosine, we have, pupunta ng plus infinity na sa loob ng hyperbolic cosine kasi ito sa nakuha natin kanina. So, dito lamang sa part na ito yun. So, as x approaches plus infinity, hyperbolic cosine approaches plus infinity as well. So, this approaches plus infinity. And then, finally, ang e to the plus infinity ay pupunta rin ng plus infinity. Okay? So, kung sakasakaling hindi naman 0 yung cosine inverse for the negative x as x approaches plus infinity, then kaya natin makompute ito. Kasi ang indeterminate lang naman kapag nakamultiply sa plus infinity ay yung 0, di ba? So, check natin. So, we start with negative x. Ang negative x, pupunta lang yan ng negative infinity. And then, ngayon, meron tayong 4 to the negative infinity. So, pwede mo yung isipin as 1 divided by 4 to the infinity lang. So, you are dividing 1 by 4 times 4 times 4 times 4 times 4 na infinitely many times. So, the denominator becomes very, very, very large positive number. So, we just get here 0. Next. Cosine inverse of 0. What is the domain of the cosine inverse function? Di ba siya ay negative 1 to 1? So, si 0 pasok naman sa domain, hindi naman endpoint. Kaya we can simply evaluate. So, we get cosine inverse of 0. But what is cosine inverse of 0? This is equal to pi over 2. Tama ba? Pi over 2 yung value yan, ha? Kasi ano bang angle yung nabibigay ng cosine na equal sa 0? It is pi over 2. And hence, we get plus infinity times pi over 2. So, positive constant times plus infinity. So, infinity pa rin and the sign is retained because the constant we are multiplying with the plus infinity is also positive. Ayan na, this is our answer. So, that's it for this topic. And this topic 1.7 concludes the first unit of Mathematics 21. Again, kung natapos nyo na lahat ng pinapanood ko sa inyo, yung 4, sa October 6 ay free day muna tayo. Wala tayong scheduled na bagong activity. However, I want you to use that day to catch up. Kung okay naman na kayo, confident na kayo sa alam niyo so far, then you can use that as rest day. Pero kung sa tingin niyo kailangan niyo mag-catch up, then I am available for consultation pa rin kapag class hour natin on Tuesday. And then on Wednesday, deadline po ng homework 3. At the same time, simula na rin nung Unit 2. Okay po? So, sige, see you all next week. And maraming salamat, class!